Hello, I'm very pleased to be able to talk with you about drainage water management, a practice I often speak about, but never with the title of speed science before, a concept that I just love. Being a generally impatient person, we can learn so much in a short time. Looking at a photo like this of a beautiful farm in Minnesota, or being on the Amish farm last night, for those of us who are privileged to be there, it's often hard to remember that one of our major problems is excess water, which is so frequent across the Corn Belt and is usually one of our biggest problems, just not this year. We have to remember that usually it is, and it leads to problems like this. We've got surface runoff and associated pollutants, and it's just hard to work the field when we have our naturally poorly drained soils. So because of that, we have tile drainage across much of the Corn Belt. This is something that it's hard to see. Many of you probably know that it's there, as I did for many years until I was finally able to see some installed. But it's fun to go out on a field day such as this and see how the large drain plows pull it through the soil. There's tile drainage in many places, but especially, as you can see here, it's the Corn Belt that overlaps very much with this project. So it's one of the main systems that we really need to study, and the practices that are being tried are in relation to systems that are tile drained. But I did want to start, since we're talking about drainage water management, it really only makes sense to contrast it to tile drainage, or to think about the effects of tile drainage first. So before I look at the effects of drainage water management, we're going to look briefly at the effects of tile drainage on these widespread systems. Now, this is a photo from Minnesota, also of newly installed tile drains, one of the few times when you can really see what the fields look like. Okay, so I'm going to look at each of those in turn on this nice photo from Dan Janes. The tile drains change the primary flow path, is what's their most important impact. Water moves through the soil profile instead of going off the surface or directly into groundwater and into the tiles, and it picks up a lot of nitrate along the way. It has benefits like reducing surface runoff and all the pollutants that are associated with surface runoff. So those are that's a positive thing about tile drainage. The effect on carbon, I'm only going to use one here. I just wanted to say that without tile drainage, a lot of our cropland wouldn't be productive at all. So there are a lot of transformations just by the fact that we're growing crops, probably others that I don't know about. But nitrogen is the one we look at a lot. It's possible that there's some decrease in organic nitrogen loss, which would be with erosion and the fact that that's reduced. But the big one, so I gave it bold yellow, is that it increases the nitrate loss through the tiles and then into our ditches and then into our streams and rivers and finally into the Gulf of Mexico, where, as you know, it causes hypoxia, and that's really been quite well linked to nitrate coming from tile drains in our Corn Belt. So that's what's led more than anything to this concept of drainage water management. The general idea we're getting at here is that you manage drainage by only draining what you need to drain for crop production. So it doesn't in any way reduce the drainage that you need, but if you remember, the systems are typically just installed as tubing or pipes that drain anytime. I was thinking of the earlier example of the bathtub with the drain open a little bit, and that's how our typical drainage is. The way we do this is to install water control structures in some of the main drain lines, and I'm showing the most typical one here. What it is really a box that has boards that sort of create a dam, and it gives us the potential to control the height of the drain outlet. And so in this sort of image that we often use. It's used on the sheet here and the poster, so you can look at it in more depth. After harvest, we raise this dam or raise the outlet height of the water, and that allows through the winter there to be much less drain flow. We're not closing it off entirely, but we're raising the outlet. And then before we need any field operations in the spring, we lower the outlet completely so that it's back to the height that it would have been without the drainage water management system. And then after planting, there's the option of raising it a certain amount to store more water, which can help crop growth. Doesn't always work that way, but that's the hope, that's the idea. The outlet can be controlled by inserting or removing the boards in the structure. This is one of the most famous photos with Norm Fauzi. There are now automated gate structures also available. The way we're measuring it in this project is that most of us have paired fields. It's hard to use small plots with drainage water management because they influence each other. If you raise the water table in one plot, it's going to raise those next to it. So we've taken fairly large fields and tried to pair them as well as possible with similar soils, yields, et cetera, and then controlled the drainage in one of them. So this is one of our fields. It happens to be across the ditch, which gives it a good separation from the conventionally drained one. And that gives us a chance to look at the effect of drainage water management on those same three things that's the focus of our project: the water, nitrogen, and carbon. So on water, again, obviously if you raise the outlet, the primary effect is that the water table is higher and therefore the soil profile is wetter during those times when it's raised. The water will still leave the field. There's a limit to how much you can fit in the soil or in the bathtub, but it'll leave through different pathways than it would. Perhaps more evapotranspiration, possibly more surface runoff, some leaching into deeper layers, and lateral subsurface flow. And it's those pathways and what kind of pollutants it carries with them that's one of the important things that we need to find out more about. What we know of the effect of drainage water management on nitrogen is that the nitrate concentration remains about the same, but there is decrease in the nitrate loss from the field, or the loading that comes off the field, because the drain flow is reduced. There is a possible increase in the kinds of nitrogen that are attached to soil if there is increased erosion, but that's going to be a smaller source of N. So we're pretty sure that it results in less nitrate. There is a possibility that it can increase nitrous oxide from the field, and there's a lot that remains to be understood about this process, especially by me. I know I don't understand most of what needs to be understood, but I think others don't either. When we look at the whole system, there might be, if denitrification is taking place here instead of further downstream, there might be differences there. So that's something we certainly need to learn more about. But I do know enough that it's a bad thing, so we need to get it out. Here's an example of our nitrate loads from one of our pairs. You see that the blue managed drainage, the nitrate load is sometimes less than coming from the free drainage field, but not always. So it's very complex relationships that take years of study to really piece together. And hopefully piecing together across the different sites will be successful at helping us to understand this more as well. The different individual sites that have been published find nitrate load reductions, very consistently nitrate load reductions, but the amount varies, typically around 30%, but from 15 maybe way up to 75% in some places. And so finally, looking at the effect of drainage water management on carbon is based on the fact that it has that potential to affect yield. So if the crop yield is increased, then it will keep more of the carbon and build up the carbon in the soil. So let's look at crop yield a little bit. There has been quite a bit of study that's gone on to that. Of course, results are all over the map. In general, they're positive. In general, there's an increase, but very small. And sometimes, in some years, the increase can be negative. So this is 4 quadrants of the field in Indiana that we're studying. 2 of them managed, 2 of them free. You see the yield maps, and of course, they're quite different. But we are piecing that together also, and we hope to combine across sites to figure out these yield impacts. One of the reasons that it's not predictable and not consistent is the yield is only increased if we successfully raise the water table at the time of year that the crop can use it. And so that would be after planting. If we have enough rain that it can raise the water table, then we can store it. But in years like 2012, there was no rain that came after planting enough to even hold back. So it varies with our precipitation and also the particular management that we're using. So that's the crop yield, will affect what kind of carbon impacts they are. There are also others, like if the soil is wetter, there would probably be less decomposition of organic matter, and therefore it will slowly build up organic carbon. But I would say that I at least look forward to learning from many other members of this team more about these other effects. And I think it's a real benefit of looking at this practice together. So finally, I just want to say this year's drought, I'm sure that you, like I, have been thinking a lot about what's the message, what are we teaching in this, there's this teachable moment, but what are we thinking about? And I think resilience is really a good word that we can all think about. And drainage water management does have the potential to help the resilience to the droughts that we know will continue to become more frequent and more severe. So again, in summary, drainage water management seems to have potential, possibly to increase resilience to drought by storing the water. It can help to gain more carbon in the soil if we are successful at increasing yields. And certainly draining only what we need to drain can decrease corn's nitrogen footprint. And I'm sure that there are other effects yet to be discovered, and that'll be a great thing about this project. Thanks.